get quiet on set in 5.
Good evening from Griffith Observatory in Los Angeles, California. Thank you for joining us for our live broadcast of the southernmost moonrise along the eastern horizon. I'm Mark Pine, the Deputy Director of Griffith Observatory, and this is the observatory's 90th year of operation, and the moon is helping us celebrate by doing something it hasn't done in almost 18 years. It is rising and setting as far north and as far south as it is ever seen. This phenomenon is called the Major Lunar Standstill, and it's happening each month during 2024 and 2025. After December, it won't happen again for another 18 years. Tonight's cheering and unusual astronomical event is part of Griffith Observatory's 2-year campaign to follow the greatest monthly excursions of the moon. Our broadcasts are brought to you as a public service by Griffith Observatory, Griffith Observatory Foundation, the City of Los Angeles Department of Recreation and Parks, and of course, the law of gravity, which is responsible for the moon's behavior.
This is Griffith Observatory Director Dr. Ed Krupp here. The sun set earlier tonight at 8:05 p.m. Pacific Daylight Time. Observatory cameras are now targeting this view of the southeast horizon from below the observatory's South Promenade and East Terrace. In a short time from now, the full moon will rise on this line just about as far to the south as we ever see it. The moon will appear over the distant mountain ridge at about 9:02 p.m. Pacific Daylight Time, and the Griffith Observatory live stream broadcast team is prepared to catch that moonlight. The broadcast team includes Griffith Observatory Deputy Director Mark Pine, Observatory Theaters Manager Patrick So, Production Engineer Matthew Burlando, Observatory Astronomical Observer Vanessa Alarcon, Digital Communications Coordinator Pixie Iwata, Video Production Coordinator Ella Ritz, Observatory Carpenter Grant Armstrong, Special Assistant Jennifer Wong, and Stage Manager Michael Noble. Now, we first broadcast the southernmost moonrise in June and July last year. Since then, we've also transmitted the southernmost moon set and the northernmost moon rise live to the world. The moon hasn't been rising and setting this far south since 2006. Its orbit is now tilted at the greatest angle outside the path of the sun. Those white disks represent the moon on its path, and the other circle is the sun's path. On the ground, this means over the rest of the year, we'll still see the most northern and southern moonrises and moonsets the moon ever reaches. Here again is our major standstill moonwatch view. The southernmost moon will appear on the line of lights that extends across the pavement. The greatest excursions of moonset are marked with lines on Griffith Observatory's lower west terrace, along with lines for the solstice and equinox sunsets, and for moonsets when the monthly excursion is the least, at minor standstill. The observatory was still under construction for renovation and expansion at the last major standstill in 2006. The stone for the line had not yet been placed into the pavement. Here, in fact, is the major standstill northern moonset on January 28, 2006. Now, between now and December, the moon will, each month, rise and set as far north and as far south as it ever can, at those extreme points in the diagram that show the moon as the white disks. And although we call this period the Major Lunar Standstill, the moon doesn't really stand still. Its monthly excursions just reach roughly the same maximum limits each month for about 2 years. Now, the sun does something similar, but it does it over the course of a year. In this illustration of the sunrise limits on the eastern horizon, the June sun is rising on the left as far north as we ever see it, and 6 months later, in December, it rises at its southernmost limit on the right. To the unaided eye, the position of sunrise and sunset at these times of year does not seem to change for about 3 days. The sunrise and the sunset seem to stand still, and the time when this happens is called a solstice, which means sun still. The Griffith Observatory cameras are still targeting the southeast horizon, where the southernmost moon will soon rise. Now, if we think of the sky as a hemispherical screen, like a planetarium dome, we can imagine how the sun, moon, planets, and stars all rise somewhere from the eastern half of the horizon, on the near side in this view, and from there they climb up the sky to their greatest height and then head back down to the western half of the horizon on the far side of the dome. The celestial objects all rise and set like this because the Earth is spinning on its axis, and that makes the sky seem to turn around the north celestial pole, a spot directly above the Earth's north pole. If that were all that moves, the sky would be simple. But other objects, like the sun, moon, and planets, all move around the sky on their own paths at different rates. Here we imagine the sky as a sphere with the Earth at the center, and we can see half of the sky overhead, but the other half is hidden by the Earth beneath our feet. Now, the sun's path through the entire sky is called the ecliptic, and it is just a reflection of the Earth's orbital motion around the sun. The sun takes about 365 days, a year, to complete its circuit, and the tilt of the sun's path shifts the sunrise from north to south and back to north again in a year. Now, each month, the moon circles the Earth in 27 days, and the tilt of the moon's orbit guarantees that the moonrise will migrate from north to south and back to north again in that time. So the moon does in a month what the sun does in a year. It moves from north to south and back again. But the moon does something else. The moon's monthly limits gradually change. Over 18.61 years, the moon's limits move from outside the sun's limits to inside the sun's limits, and then back outside the sun's limits again. The moonset lines on the lower west terrace of Griffith Observatory make this obvious. The gray lines for the northern moon's inner and outer limits flank the gold summer solstice sunset line that points to the northwest. The gray lines for the moon's southern inner and outer limits flank the gold winter solstice sunset line that points to the southwest. When the moon rises and moonsets reach these limits, the limits don't seem to change much from month to month. These periods are the standstills, one at the moon's inner limits and another at the moon's outer limits. The moon's limits still change through these periods, but the change from month to month is small, just as the daily change of the sun's position at the solstices is small. And that's why we call the moon's limits the lunar standstills. We are now in the season of major standstill, the time when the moon's monthly limits are far outside the sun's annual limits. The extreme moonrises and moonsets are farther north and farther south than the solstice sunrises and sunsets. In another 9.3 years, the limits for the moonrises and moonsets will be inside the solstice points and will be at the minor standstill. The monthly limits then will gradually increase again, and in 2042 we'll have the next major standstill. So mark it on your calendar. The moon behaves this way for two reasons. First, the moon's orbit is tilted a bit compared to the Earth's orbit around the sun. The line just connects the Earth and the sun there, represents that Earth's orbit, and the moon's orbit is easily seen as being tilted. Second, thanks to the gravitational pull of the sun, the moon's orbit swivels. That changes the angle of lunar excursion and the amount of the moon's reach. This Fisk planetarium animation shows how the rotation of the moon's orbit changes the angle at which we see it. These edge-on views of the Earth, the sun, and the moon show how the moon's orbit flips from a greater angle to a smaller angle, and back again with respect to the sun. And although the varying limits of moonrise and moonset are noticeable over time, most people, including professional astronomers, have no experience with this aspect of the moon. You have to track the moon systematically month after month for several years to realize the moon is doing this. And you would have to track it for several 18.61-year cycles to see and understand the full pattern. And that's what we're doing at Griffith Observatory tonight. Okay, we're still several steps ahead of the Major Standstill southern moon, which will show up soon. Now, despite the difficulty in mastering the lunar standstills, some investigations of archaeological monuments, particularly Stonehenge, have led some investigators to propose that lunar standstill alignments were designed into some ancient and prehistoric sites. In the 1960s, C.A. Newham and astronomer Gerald S. Hawkins independently identified lunar standstill alignments in the station stones rectangle at Stonehenge. The rectangle enclosed the main circle of the stones and was constructed earlier, perhaps 4,500 years ago. The long sides of the rectangle coincide with the directions of Major Standstill southern moonrise and Major Standstill northern moonset. Here is the view to Major Standstill southern moonrise, and here is the Stonehenge station's view to Major Standstill northern moonset. Hawkins also proposed sight lines between certain gaps in pairs of archways formed by the large sarsen stones, erected perhaps 500 years later. This pair of openings accommodates the Major Standstill northern moonset. Stonehenge was not, however, the first prehistoric monument assigned a major lunar standstill alignment. In 1908, British naval officer Boyle Somerville published a Major Standstill northern moonrise line for the Callanish stones in Scotland's Outer Hebrides. In the 1980s, Gerald and Margaret Pontine instead favored an alignment down the long axis, more or less, of the circle to the transit of the low southern moon. Here, that transiting moon hugs the horizon in June 1987. The late Aubrey Burrell was the leading expert on prehistoric stone rings, and he identified Major Standstill southern alignments in the recumbent stone rings in northeast Scotland. The big recumbent stone on the moon's line operates like a stage across which the southern moon dances. This is the view to the southwest from the center of the Castle Fraser stone circle. Jack Eddy, an American solar astronomer, spotlighted a 2,000-year-old Major Standstill northern moonrise alignment with the axis of the prehistoric Hopewell Circle and Octagon mounds at Newark, Ohio. Stephen Patricia reconstructs here Newark's Major Standstill northern moonrise on that line. An ancestral Pueblo great house, about 1,000 years old at Chimney Rock National Monument near Pagosa Springs, Colorado, accompanies the restricted view of the Major Standstill northern moonrise framed by the distinctive rock pillars, a little bit off in the distance there. Some believe the great house was built on this demanding mountain ridge to accommodate the northernmost moon in the Chimney Rock Gap. Griffith Observatory astronomical observer Vanessa Alarcon photographed the northernmost moon in October 2023, and Dr. Amanda Bosch of Lowell Observatory caught the December 2023 full moon at Chimney Rock. The Griffith Observatory remote live-stream internet broadcast team captured and transmitted worldwide the Major Standstill northern moonrise at Chimney Rock last September and October, and those broadcasts are available on the Griffith Observatory website. At this time, the broadcast team is scheduled to return to Chimney Rock for another broadcast in September. Deliberate inclusion of lunar alignments in ancient and prehistoric monuments has not been proved and remains questionable. Griffith Observatory, on the other hand, possesses intentional lunar alignments, and through the rest of 2025, Griffith Observatory will broadcast selected moonrises and moonsets at the moon's maximum excursion.
We are now about to witness in real time the Major Standstill southern moonrise from the southeast corner of Griffith Observatory, along a moonrise line pointed southeast over Elysian Park, Santiago Peak, and on to Palomar Mountain. Moonrise is scheduled for 9:02 local time, so it'll just be a few more minutes from now. That said, we are experiencing fairly murky conditions here tonight, so it may take a minute or two or several longer to see the moon because of the haze on the horizon. Whenever you see the moon, we hope you enjoy its rising, accompanied by music from the shows from our Samuel Ocean Planetarium. Hello again, everyone. This is Mark Pine from Griffith Observatory. We're glad you're here for our Major Lunar Standstill Southern Moonrise. And as you can see, the moon has risen. You can see it. Almost the entire disk of the moon is now visible above the southeast horizon. It rose out of the murkiness around the horizon because there's a lot of humidity in the air right now. And now you're going to see the moon rise much more clearly as it gets above the murk and the clouds. And in a few moments, we should have a pretty spectacular, nearly full moon. And so we hope you continue to enjoy this broadcast of the Major Lunar Standstill Southern Moonrise, live from Griffith Observatory in Los Angeles, California. Thank you for joining Griffith Observatory's broadcast of the June 11th, 2025 Major Lunar Standstill, Southern Moonrise. While the moon may be standing still, Griffith Observatory never stops moving, so we hope you will join us, weather permitting, in just over 4 hours for our live broadcast of the transit of the moon across the meridian arc in the Gottlieb Transit Corridor on the west side of the observatory. Like all of our broadcasts, this rare and unusual sight will be brought to you by Griffith Observatory, Griffith Observatory Foundation, and the City of Los Angeles Department of Recreation and Parks. We hope you will also join us online for future astronomical broadcasts and for our monthly All Space Considered program. For all of us here at Griffith Observatory and the City of Los Angeles, we wish you a peaceful and pleasant evening. Good night.